Hello. In this video, I will do some examples, problems converting metric system using the three methods. So yes, we're gonna start actual dosage calculation using the three methods, which is the dimensional analysis, ratio and proportion, and move the decimal point method. So yes, so in example one, we have to convert 1.6 meters to centimeters. So before you start, you need to know you need to memorize the metric system prefix. Um, you could just write these down, or you can download the worksheet. I mean, yeah, download the PDF. But if you just copy this down and put it on your notes, you should be fine as well. So this is something you must memorize. So we know that one micro is the same thing as 1 million. So 1 gram is 1 millionth of mcg. Milli represents 1,000. So we know that 1 gram is 1,000 mg. So yeah, go ahead and write all these in your notes because we're going to use these. Centi means 100ths. So 1 meter is the same thing as 100 centimeters. Deci means 1/10, so we know that 1 liter is the same thing as 10 liters, DL. Kilo means 1,000, so we know that 1 kilogram is the same thing as 1,000 grams. Okay, so go ahead and copy this down because we will use these. We're going to definitely use these. So yeah, we have to, in example one, we have to convert 1.6 meters into centimeters. So we're going to do the three methods: dimensional, analysis method, ratio and proportion, and then move the decimal method. So let's start with a dimensional analysis method. Honestly, I like this method. I like dimensional analysis and ratio and proportion method the most because it's pretty straightforward. So dimensional analysis is almost like stoichiometry in chemistry. So you're going to set up fractions. So what we are given is 1.6 centimeters, right? And I'm going to do it little times. You can use parentheses or bracket. I mean parentheses, and then write a fraction. And then I'm going to put, my bad, this is not centimeters. This should be meters. This was a mistake. So it's 1.6 meters, and we got to convert it to centimeters. So Um, over here, we're going to put meters, and then on the top, we're going to put centimeters. So this is where you fill in the blanks. So according to the chart, the rules, we know that 1 meter is the same thing as 100 centimeters. So you just have to know, copy this rule down. So we know that 1 meter is the same thing as 100 centimeters, right? Right here. 1 meter is the same thing as 100 centimeters. So yeah, if you need to copy it, go ahead and copy or pause the video. Okay. Then, so yeah, so this one has a denominator one, and then remember when you're multiplying fractions, so you multiply across. So if you look at the units carefully, what cancels out? The meters, because the meter is the same on the top and bottom, so they cancel. So you're now left with centimeters, and then just multiply it out on top. So, uh, it's going to be 1.6 times 100. And then this 1.6 originally didn't have anything on the bottom, but it does. It's just an invisible one. So if you have nothing on the bottom in the denominator, it's just a 1. And then what's 1 times 1? 1. So if you put it all together, what's 1.6 times 100 over 1? You said it, 160 centimeters. Okay. Okay, that's our answer. We do not have to round. Um, okay. So yeah, that is the dimensional analysis. Now let's do the other method, ratio and proportion. I like this method the best, actually. It's pretty straightforward. So how do you set up a ratio and proportion? You set it up as two separate fractions, and you can set it up any way you like. Um, so you could put meters here, and then you could put centimeters on the bottom. But then that means that over on the right side, this has to be meters and then centimeters, right? And then you fill in your blanks, fill in what you have, and fill in your unknown. So we should only have one unknown. That's true. So we were given 1.6 meters. So you put 1.6 meters on the top. And then we want to know how many centimeters. We don't know. We'll call it X. And then according to our chart, for 1 meter, there's 100 centimeters, right? So you could have also set it up like this. It wouldn't be wrong. You could put on here, you could put centimeters here and then meters on the bottom. The same thing here. This could be centimeters and then meters. So the keynote is this has to be the same with this, and then this has to be the same as this. That's the important part. Okay, then what I'm going to do is cross multiply. Okay, so what's 1 times x? X. And then it's 1.6 times 100. Okay. And you get 160 centimeters. Right? Not too bad. I really love that method better. Yeah. My least favorite is the next method, which is well, right. So my least method the next one is move the decimal. Okay. So how do we do this method? Move the decimal point method. So what you gotta know is you need to figure out, so what we are given is 1.6 meters, and we got to figure out how many centimeters we have, right? So what you need to know is we are going we are going to a larger unit measure to a smaller unit measure. So this is also important. So we are going from a larger unit to a smaller unit. So the thing you need to know is if you're going from a larger to a smaller, you're going to move the decimal to the right. If you're going from a smaller to a larger, you're going to move it to the left. So keynote. If Okay. So yeah, so if you're going from a larger a larger unit to a smaller unit, you're going to move it to the right, move the decimal place to the right. And if you're going to a smaller to a larger, you're going to move it to the left. So what we have is we are definitely going from a larger, right? Meter is pretty large, and then centimeter is smaller. So we are going from a larger unit to a smaller unit. So we're going to move the decimal place. Uh, we're going to move it two decimals to the right. Why are we moving it two decimals to the right? Because we know that 1 meters is 100 centimeters. See how there's two zeros? That means we're going to move it two places to the right. So go ahead and move this decimal two places to the right. So that'd be 1, 2. So that's going to be 160 centimeters. Okay. Okay, so let's move on to example two. Hold on. Let me get. Okay, so example two, we are given 450 mcg, and we got to figure out how many mg there is. So we're going to do the three methods, dimension analysis. So let's set it up as how do we set it up as a dimensional analysis method? So we're write it as a fraction. So the 450 mcg times, and then you're going to make a fraction, and then on the bottom you're going to put mcg, and then on the top it's going to be mg. Okay, and then use your table. So what's the relationship between mg and mcg? So we know that for 1 mg, there is 1,000 mcg. Okay, and then when you're multiplying fractions, multiply across. So this has an invisible denominator, 1. So, and then as you can see, that mcg cancels. So your final units will be mg. And then go ahead and multiply across. So what's 450 times 1? And then on the bottom, what's 1 times 1,000? So that's 450 over 1,000, right? Now, put this in the calculator and you get 0.45. So you must include this trailing zero, otherwise it'll be wrong. So you're going to say must, I mean, not trailing zero, leading zero. So the zero between in front of the point 4 is a leading zero. So you must include leading zero. My mistake. Not no trailing zeros. Okay, so pretty, here's your answer, 0.45 mg. Okay, now let's do ratio and proportion method. So we're going to set up like a fraction. Okay, so you can set up any way you like. So you could put mcg on the top, and then this has to also be mcg. And then on the bottom, you could put mg, and then this has to be mg, right? So remember, this unit has to align with this unit, and then this unit has to align with this one. And then fill in your blanks. So we know that we were given 450 mcg, and then we don't know our mg, so we'll call it x. And then we know that the relationship between mcg and mg, we know that 1 mg, there's 1,000 mcg. Okay, go ahead and do step two, cross multiply. So So it's going to be x times 1,000. So it's 1,000 x equals, and then what's 1 times 450? 450. Divide this by 1,000. So what's 450 divided by 1,000 is 0.45 mg. And that's it. And remember, always include this leading zero. Okay. Then let's move the decimal. Move the decimal method. So what you need to know is, are you going from larger to smaller? So what do we have? We were given, so yeah, we are we are going from a smaller unit. So we started with MCG, which is pretty small, right? We're going from a smaller unit to a larger unit. So we're going from a smaller to a larger unit. So you must move the decimal uh 3 units, 3 units to the left. Okay. So yeah, we were given 450. Now, where is the decimal when you don't see one? It's at the very end. So if you don't see a decimal, it's at the very end. So we're gonna move it 3 places to the left. So why are we gonna move it 3 places? Because we know that 1 mg is 1,000 mcg. So there's 3 zeros. That's why I'm gonna move it 3 places to the left. So move it 3 places to the left. 1, 2, 3. Now you do must include this leading zero, right? But do not include this trailing zero, right? So you must include this leading zero, but do not include trailing zero. And you get 0.45 mg. Good. Mm, Not too bad, right? Pretty straightforward. So we're gonna do quite a few examples. If you kind of get the hang of it, you don't have to do all the examples, but I'm gonna do, I think, up to like 18 examples. So let's continue. So yeah, I want you to, this is why I did a lot of examples so you can understand. So let's start with example 3. So example 3, we have 0.3 kilograms convert to how many grams? So first method is dimensional analysis method. So go ahead and set it up. So it's going to be 0.3 kilograms times. So you're going to write it as kilograms on the bottom, and then on the top, it's going to be grams. Excuse me. So what is the relationship between grams and kilograms based on your chart? We know that 1 kilogram, there is 1,000 grams. Okay, and then put an invisible one under the 0.3 if that helps. And then what happens to the units, the kilograms disappears, and then you're just left with grams, and then you just multiply across. So what's 0.3 times it by 1,000? And then on the bottom, it's what's 1 times 1. So what's 0.3 times 1,000? That is going to be 300 grams. So you must include these zeros. Yeah, so it's just 300 grams. Okay, now let's do ratio and proportions. So set it up as two fractions. You could put kilograms on top, and then grams on the bottom, and then kilograms on the top, grams on the bottom. You could do vice versa. You could put grams on the top, kilograms on the bottom, and then this has to be grams on the top and kilograms on the bottom, right? So let's see. We were given 0.3 kilograms, and then we want to know how many grams, so that's our unknown. And then what is the relationship between kilograms and grams? We know that for 1 kilogram, there's exactly 1,000 grams. Okay. Go ahead and cross multiply, so 1 times x is x, and then 0.3 times it by 1,000, and you get 300 grams. Okay, what about move the decimal method? So where are we going? So we are going from a large unit to a smaller unit. So what you're going to have to do is move the decimal 3 places to the right. Okay. So what we were given is 0.3. And here's the decimal. So we're going to move it 3 places to the right. So it's going to be 1. So it's 1, 2, 3. Now, you don't need the 0 here. And so your final answer will be 300. You don't have to put this decimal here. It's just fine as 300. Okay, pretty simple, right? Um, hey, let's practice more. Sample 4, we have 78 grams and we got to convert it to kilograms. So let's start with dimensional analysis method. So you're going to put 78 grams here times, and then grams on the bottom, and then kilograms on the top, right? Go 1 here. And then what's the relationship between kilograms and grams? Based on the chart, we know that 1 kilograms, there is 1,000 grams. Okay, the grams units disappear because they're the same on the top and bottom. So you're left with kilograms and then multiplied across. So what's 78 times 1? And what's 1 times 1,000? So that's 1,000. Okay, you put it all together. 78 times 1 is 78. What's 78 over 1,000? It's going to be 0.078. So you must include this 0, and you must also include this leading 0, right? So, yep. Okay. Now let's do ratio and proportion. So, what was I? So how are we gonna set it up? So you put grams here, kilograms on the bottom, grams here, kilograms on the bottom, right? So we were given exactly 78 grams. We don't know how many kilograms, so that's our unknown. And then based on their chart, we know that for 1 kilogram, there's 1,000 grams. And then go ahead and cross multiply. So 1,000 times x is 1,000 x. And then what's 78 times 1? What's 1,000? versus 8. And then solve for x, you're going to divide this by 1,000. And you get 0.078. Okay, let's move the decimal place method. So we are going to a smaller to a larger unit. So move. So we got to move it 3 units to the left. Why 3 units? Because remember, for one kilogram, there was 1,000 grams. So it's really just these amount of zeros, right? There's 3 zeros. So let's see. So we had 78. Um, where was the decimal? If you don't see it, it's right here. So, and we're going to move it 3 units to the left. So 1, 2, and then trailing zero, and then dot. I mean, leading zero, then dot. So it's going to be 0.078. And then you have to add this extra zero. So that's going to be, don't forget your, don't ever forget the leading zero. Okay, so this invisible zero is your leading zeros. Yeah. Example 5. For example 5, we have 18 grams converts to how many kilograms? So dimensional analysis is like this. So for 1 kilo, so put grams on the bottom, kilograms on the top. So for 1 kilogram, there is 1,000 grams, and then just multiply across. So the grams disappears, then you're left with the kilograms. So 1,800 times 1, and then on the bottom was 1 times 1,000. Put it all together, you get 1,800 over 1,000, and you get exactly 1.8 kilograms. Okay. Okay, ratio and proportion method. So let's see. So you could put grams here, kilograms in the bottom, grams here, and kilograms in the bottom. So we are given exactly 1,800 grams. We need to figure out how many kilograms, so that's our unknown. And then what's the relationship between grams and kilograms? We know for 1 kilogram, there's exactly 1,000 grams, right? Based on the chart. And then all you got to do is cross multiply. So it's going to be 1,000 x equals 1,800 times 1 is 1,800. Okay, go ahead and solve for x. So get rid of this 1,000 by dividing both sides by 1,000. And we'll get 1.8 kilograms. Okay, move the decimal method. So we are technically, so we were given grams and we want to convert to 2 kilograms. So grams is pretty small. So we are going smaller to larger unit. So we are going to move the decimal. Uh, three three decimal places. We're gonna move the decimal three places to the left. Okay. So here's 18. We were given 1800. Where's the decimal? If you don't see it, it's at the very end. And then we're going to move it three places to the left. Why? Because we know that 1 kilogram, there's 1,000 grams. So it's just basically these zeros. So move it three places to the left. So it's one, two, three. So you're left with 1.800. Now, do we include these trailing zeros? No, we never include these trailing zeros. So that is why it's just 1.8. Okay, example 6, we have 0.6 kilograms converting it to grams. So kilogram is pretty large, and then we're going to a smaller unit because grams is kind of small. So we're going from a larger unit to a smaller unit. So let's start with the dimensional analysis method. So you can start with 0.64 kilograms times, and then fractions, and then put kilogram units on the bottom, and then grams on the top. Put an invisible one here. What is the relationship between grams and kilograms? We know that 1 kilogram, there's 1,000 grams. Okay. And then as you can see, the grams disappears. Whoops, I mean the kilograms disappears, and then your final units are grams. So you just multiply when we're multiplying fractions, multiply across. So 0.64 times it by 1,000. And then on the bottom, what's 1 times 1? 1. Yeah, you probably know that you could do this in your head, but I'm just doing every step so you don't get confused. So what's 0.64 times 1,000? That's 640 grams. Right? Yes, you include the zero because 640, it's wrong if you say 60, 664, 64, right? That's wrong. So you must include the zero. Okay, ratio and proportion method. So let's do that. Okay, let's see here. We are given 0.6 kilograms, and then, oh, so you can put kilograms on the top and then grams on the bottom. We hear this is kilograms and then grams. So we were given 0.6 kilograms. We don't know how many grams, so that's our X. And then for 1 kilogram, there is exactly 1,000 grams. Okay, step 2, cross multiply. So what's 1 times X? X. And then 0.6 times 1,000. What's 0.6 times 1,000? 640. And yeah, 640 grams. Okay, so move the decimal method. So we said before, kilograms is fairly large and grams is kind of small. So we are technically going from a larger to a smaller unit. what you're going to do is move the decimal 3 units to the right. Right? If we're going from a larger to a smaller, you move it to the right. Why 3? Because we know that 1 kilogram, there's going to be 1,000 grams. So it's like these amount of zeros. So let's see. It was 0.64. So we're going to move it uh, 3 units to the left. So, I mean, 3 units to the right. So it's going to be 1, 2, and then 0 dot. So you don't include this trailing leading zero, so that's going to be 640. And then you don't need this decimal, so 640 grams. Okay, example 7. We have 375 mcg converts to how many mg? So yeah, let's do dimensional analysis. So we were given exactly 375 mcg times, and then put mcg on the bottom, and then on top it's going to be mg. So we know that for 1 mg, there's 1,000 mcg, and then put like an invisible one here, and then multiply across. So 375 times 1 is 375 times 1. And then on the bottom, it's what's 1 times 1,000 and what? Yeah. And then mcg cancels, and then you're left with mg. So what's 1 times 375? 375. What's 1 times 1,000? 1,000 mg. Okay, what 375 divided by 1,000? That is 0.375, and you must include leading zero. So 0.375 mg. Okay, ratio and proportion method. So it's going to be like this. So you put mcg here, and then on the bottom, mg. mcg here, and then mg. So we are given 375 mcg, and then unknown is x. And then for 1 mg, there's 1,000 mcg. Okay, cross multiply, so 1 times x times 1,000 is 1,000x. And then 1 times 375 is 375. Okay, solve for x, you're going to divide both sides by 1,000. And you get 0.375. Okay, include this, include the leading zero, and you're good. Okay, move the decimal move the decimal place. So what we were given, we were given mcg to mg. So what is that? So we are going, mcg is pretty small, and then mg, what is it? Yeah, mcg is pretty small and milligrams is larger. So we are going smaller unit. So what we were given, what were we given? We were given exactly 375. Where's the decimal? Right here. We're going to move it three places to the left. So it's going to be one, two, three, and then you must include the leading zero. You got to put this extra zero. So yeah, you must include leading zero. Final answer is 0.375. Okay, sample eight. Sample eight, we have 56 mcg converts to how many mg? So let's start with dimensional analysis method. Okay, so as you can see, I put mcg on the bottom because I want the mcg cancel. And then what's the relationship between mg and mcg? So we know that for 1 mg, there's 1,000 mcg. Okay, the mcg cancels, and then multiply across, so 56 times 1 over 1 times 1,000, and we get 56, right? 56 times 1 is 56, and then 1 times 1,000, and you get 0 point, yeah, 0.056, and you must include leading zero. Okay. A ratio and proportion, so we have it as a fraction. Over here, you could put mcg, and then on the bottom, you could put mg. And over here, this also has to be mcg, and over here, it's going to be mg. Okay, so we were given exactly 56 mcg, and our mg is unknown. And what's the relationship between mcg and mg? We know that for 1 mg, there's 1,000 mcg. We go ahead and cross multiply, so 1 times x times 1,000 is 1,000x, and then it's 56 times 1. 56 times 1 is 56, and then solve for x, so you can divide this by 1,000, and you get 0.056. Okay, move the decimal method. So what are we doing? We are going from a smaller unit to a larger unit, right? So we are going, so you're going to move it, so move the decimal 3 units to the left. Okay, so we were given 56. Where's the decimal? It's right here. So that place is that decimal 3 units. So that'd be 1, 2. Wait, so it's 1, 3 units left. So 1, 2, and then 0, then dot. Okay, so your final answer is going to be 0.056 mg. Oh, did I make a mistake? Yes, I did. What do I have to include this trailing leading zero, so you have to add this extra zero, right? So it would be wrong if you just put 0.056. You must include this trailing zero, leading zero right here. Okay, example 9, we have 7 mcg converts to how many mg? So start with dimensional endless method. So 7 mcg times mcg in the bottom and then mg on the top. So we know that for 1 mg, there's 1,000 mcg, and then put a little number on the bottom. And then as you can see, the mcg cancels. So 7 times 1 is 7. And then 1 times 1,000. And then your units will be mg. So 7 times 1 is 7, and then 1 times 1,000 is 1,000. And what's 7 divided by 1,000? It is 0.007, and then mg, so you must include leading zero. Okay, ratio and proportion method. So how we're gonna set it up? So we could put mcg here, and then mg on the bottom, and then mcg here, and then mg on the bottom. So for 7 mcg, we don't know our mg, so we'll call it x. And then what's the relationship between mcg and mg? So we know that based on the chart, we know that 1 mg is 1,000 mcg. Okay, go ahead and cross multiply. So that's going to be x times 1,000 is 1,000x. And then 7 times 1 is 7. Okay, solve for x. You're going to divide this by 1,000. You get 7 over 1,000. And you get 0.007. Okay, move the decimal method. So what are we doing? We are technically going from a smaller to a larger. Right? MCG is definitely smaller than MG. So what we're going to do is we're going to move the decimal 3 units to the left. Okay. So what we were given was 7 mg. So where's the decimal? If you don't see it, it's at the very end. So go and move it this decimal 3 plus this to the left. So it's be 1, 1, 2, 3, and then dot. And then include this leading zero. So that's why it's 0.007 mg. Okay, example 10, we have 850 milligrams converts to how many mcg? So let's start with a dimensional analysis method. So let's see, we're given 850 mg times mg on the bottom and then mcg on the top. Okay, so you can put a 1 here. So what's the relationship between mcg and mg? So for 1 mg, there's 1,000 mcg, and then multiply across, so 850 times by 1,000, and then 1 times 1 is 1. So what's 850 times by 1,000? That's going to be 85. And then you just count the zeros, 1, 2, 3, 4, 4 zeros. So yes, you technically have to include these zeros. So must include, so it would be wrong if you just say 85, right? 85 is not the same thing as 85 with 4 zeros, right? So yeah, 85. What is this? 850,000. 85 and then 4 zeros. MCG as my final answer. Okay, ratio and proportion method. So write it out like this. Okay, so you could put mg on the top and then mcg on the bottom. This also has to be mcg and then m. Oops, this should be mg, right? Because this unit has to be the same with this unit, and then this should be mcg. So you don't have to do it this way. You can also do it. How can you set it up? You could set it up like this. You could put mcg on the top and then mg on the bottom, right? But if you do that, this has to be mcg on the top and then mg on the bottom. Okay. So let's fill in our blanks. So we were given 850 mg, and then our unknown is x. Our unknown is mcg. And then what's the relationship between mg and mcg? For one mg, there's 1,000 mcg. Okay, based on my chart. So cross multiply, so 1 times x is x is equal to 850 times 1,000. And you get this amount, 85, and then 4 zeros. Okay, so let's move the decimal method. So we are going from a larger to smaller unit. So move the decimal 3 units to the right. So we were given 850, whereas the decimal, if you don't see it, is right here. And then you go ahead and move that 3 units to the right. So it's 1, 2, 3, dot, and it's going to be 850, and then 4 zeros. 4 mcg. Okay, example 11. We are given 0.6 mg and we got to convert it to mcg. So we're going from a larger to a smaller, right? So dimensional analysis method. So just write down what you were given, 0.6 mg, and then time. And then on the bottom, I'm going to put mg. And then on the top, I'm going to put mcg. And then you can put a 1 here. What's the relationship between mcg and mg? So if we know that for 1 mg, there's 1,000 mcg. Hey, the mg cancels, so you're just left with 0.6 times it by 1,000. And then 1 times 1 is 1. And then you may multiply across. So 0.6 times 1,000 is 600 mcg. Okay, ratio and proportion method. So we set up like this. So you could put mg on the top and then mcg bottom. So it's mg on the top and then mcg. So we were given exactly 0.6 mg. We don't know our mcg, so that's our unknown. And then for 1 mg, there's 1,000 mcg. And then go and cross multiply, so 1 times x equals to 0.6 times it by 1,000. And you get 600 mcg. Okay, move the decimal method. So we are going from a larger, right? Mg is pretty large, and then mcg is kind of smaller. So we're going to move it. So move the decimal, bring it to the right. Okay, so we have 0.6, and then move it 3 units to the right. So it's 1, 2, 3. Do not include the 0, include these zeros, right? It's going to be 600. Okay, a few more. So example 12, we have 52 mg. We have to convert it to mcg. So we're going from a larger to a smaller, so dimensional analysis. So we have 52 mg times, and then mg on the bottom, and then mcg on the top. So for 1 mg, there is 1,000 mcg. And then put a 1 on the bottom. So it's 52 times 1,000, that's 52. And then in the bottom, 1 times 1 is 1. You get 52,000. Okay, ratio and proportion, so you can set it up like this. Let's see, mg here. You can put mg on the top, and then mcg on the bottom, and then mg here, and then mcg on the bottom. So there's 52 mg, our unknown is mcg. And then for 1 mg, there's 1,000. Okay, so 1 times x is x equals to 52 times 1,000. That's 52, and then four, three zeros. mcg. Okay, so move the decimal places. So we said that we are technically going from a larger to a smaller, right? So you have to move the decimal 3 units to the right. So yeah, we were given 52. Move it 3 units. Here's the decimal, so move it three places to the right. You get 52. 1, 2, 3. Okay. Sample 13, we have 2 liters and we have to convert it to milliliters. So liters is pretty large, and then we're going to a smaller unit. So dimensional analyst. So 2 liters here times, and then liter units on the bottom, and then uh, milliliters on the top. So we know that for 1 milliliter, there is 1,000 milliliters based on your chart. Then put a little invisible one here. The units disappears. The liters disappears, and then it's 2 times 1,000 over 1. So 2 times 1,000 is 2,000 milliliters. Okay, so you could include these three zeros. Ratio and proportion method. So we're going to set it up like this. Let's see. Liters on the top, milliliters on the bottom, liters on the top, milliliters on the bottom. So we were given 2 liters, and then our milliliters is unknown. And then for 1 liter, there's 1,000 milliliters. Cross multiply, so 1 times x is x, and then it's 2 times 1,000, which is 2,000 milliliters. Okay, move the decimal method. So we are technically going from a larger to a smaller. So we got to move it 3 units to the right. So we were given 2. So we got to move this 3 units to the right. So here's the decimal right here. So go ahead and move it 3 units to the right. That is 2,000. Okay, so it's example 14. We have 500 milliliters and we got to convert it to liters. So milliliters is pretty small and liters is pretty large. So let's do dimensionals. So 500 here, 500 milliliters times, and then put milliliters on the bottom and liters on the top. You put an invisible one here. What is the relationship between liters and milliliters? Well, we know that for 1 liter, there's exactly 1,000 milliliters. Okay, and then the milliliters cancels, and then you multiply across, so 500 times 1 and then 1 times 1,000. So 1 times 500 is 500. 1 times 1,000 is 1,000. You get 0.5. Okay, you must include the leading zero. It would be wrong if you just say 0.5. Okay, ratio and proportion. So we are given um we can set it up like this: milliliters here, liters on the bottom, milliliters here, and then liters on the bottom. So we are given 500 milliliters, and then for we don't know how many liters, that's our unknown. And then for milliliters, there's 1,000 milliliters, and then for 1 liter. And then go ahead and cross multiply, so that is going to be 1000x equals to 500 times 1, which is 500. Solve for x by dividing both sides by 1,000. You get 0.5 liters. I need to move the decimal place. So we are technically we were given milliliters to liters, so we are technically going from a small to a large. We got to move the decimal 3. Okay, so we're gonna move it 3 units to the left. So we were given 500. Right, here's the decimal. So go ahead and move it 3 units to the left. So that's going to be 1, 2, 1, 2, 3 dot, and then you must include this trailing zeros. I mean, this leading zero, but do not include these trailing zeros. So it's really 0.5. I know that's confusing. You have to include this leading zero, but don't include these trailing zeros. So that's how it's 0.5. Okay, a few more. So let's say we had 4.6 liters and we want to convert it to milliliters. So we're going from a larger to a smaller. So let's do dimensional analysis. So put 4.6 here times liters on the bottom and then milliliters on the top. And put an invisible one here. So what's the relationship between milliliters and liters? So the relationship is um, for 1 liter, there's 1,000 milliliters. Okay, so the liters disappear and then multiply across. So it's going to be 4.6 times it by 1,000. That's going to be 4,600. Okay, must include these trailing zeros. Ratio and proportion, so we can set it up like this. Liters here, milliliters here, and then liters here, milliliters there. So we were given 4.6 liters, and then milliliters is unknown. And then what's the relationship between liters and milliliters? For 1 liter, there's 1,000 milliliters. So go ahead and cross multiply. So 1 times x is x, and then it's 4.6 times 1,000. You get 4,600 milliliters. Move the decimal. So let's see, we were going from liters to milliliters, so we are technically going from a larger to a smaller. So we have to move um, the decimal 3 units to the right. So we were given 4.6, move it 3 places to the right. So that's 1, 2, 3. That's how I get 4,600 milliliters. Okay, a few more. 1,700 milliliters convert to how many liters? So we're going from a smaller to a larger, so dimensional analyst. So you start with 1,700 milliliters times, and then milliliters on the bottom, and then liters on the top, put invisible one. What's the relationship between liters and milliliters? Well, for 1 liter, there's 1,000 milliliters. The milliliters disappears, and then you just multiply across. So 1,700 times 1 over 1 times 1,000. Okay, so what's 1 times 1,700? 1,700. What's 1 times 1,000? 1,000. And when you put it all together, you should get 1.7 liters. Okay, ratio and proportion. So set up like this. You put milliliters on the top and liters on the bottom, milliliters on the top, liters on the bottom. So there's 1,700 milliliters, and our unknown is liters. And then we know that from 1 liter, there's 1,000 milliliters. And then go ahead and cross multiply. So that would be 1,000x equals to 1,700 times 1. So that then divide this by 1,000. And you get 1.7 liters. Okay, move the decimal. So what are we doing? We are technically going from a smaller to a larger. So we're going to have to move the decimal 3 units to the left. So it's going to be 1,700 and then move it 3 units to the left. So where was the decimal was right here. So move it 3 units to the left. So it's 1, 2, 3. So that's going to be 1.000. You do not include these trailing zeros, so that's why it's 1.7. Okay, so it would be wrong if you say 0.01.7, and it will also be wrong if you just say 1.700. Okay, a few more. Okay, question 17. 30 centimeters converts to how many meters? So centimeters is pretty small, and then we're going to a larger. So dimensional analysis is, so we could say 30 centimeters times uh, centimeters on the bottom and then meters on the top. And put a little 1 here. What's the relationship between meters and centimeters? So we know that for 1 meter, there's exactly 100 centimeters based on the chart. So the centimeters disappear and then you multiply across. So it's 30 times 1 over 1 times 100. So that's going to be 30 over 100 and at 0.3 meters. Ratio and proportion method. So we're going to set it up like this. So you could put centimeters on the top, meters on the bottom, centimeters on the top, and meters on the bottom. So for 30 centimeters, there's unknown meters. And then for centimeters, there is 100 centimeters. And then for 1 meter, right? Cross multiply, so it's 30 equals to 100. X, divide this by 100. You get 0.3. Okay, so what we were given, so we are technically going from a smaller to a larger, so we're going to have to move the decimal place 2 places to the left. Why 2 decimal places? Because for 1 meters, there's 100. For 1 meters, 100 centimeters, right? So we count these zeros. So what we were given was 30 centimeters. The decimal's right here. So move it 2 places to the left. So 1, 2. Now you have to include the leading zero, but do not include, so you got to include this leading zero, but not this one. So that's why it's just 0.3. Okay, let's do the last one. Okay, example 18. Convert 72 meters to centimeters. So meter is pretty large compared to centimeter. So we're technically going from a larger to a smaller. So dimensional as, so 72 meters times meters on the bottom, and then centimeters on the top, right? So what's the relationship between meters and centimeters? So for 1 meter, there is exactly 100 centimeters. And then meters disappears. And then just multiply across. So 72 times 100 over 1. And that gives you 7,200 centimeters. You must include these trailing zeros, right? Okay, ratio and proportion method. So we're going to set it up like this. Let's see, meters here, centimeters there, meters here, centimeters there. So we know that 72 meters is we don't know how many centimeters. And then for 1 meter, there's about 100 centimeters. Cross multiply, so 1 times x is x equals to 72 times it by 100, which is 7,200 centimeters. And lastly, move the decimal method. So we are technically going from a larger to a smaller. So what we're going to have to do is move the decimal 2 units to the right. So we were given 72. The decimal's right at the very end. We go ahead and move that 2 places to the right. 31, 2. So that's 7,200. So you must include these zeros. And that is your final answer. Okay, so that's it. In the next video, what you're gonna do is we're gonna in the next videos we'll probably convert we're gonna convert within the household system using 3 methods. So yeah, next video will be all about household system, household system conversion.